It created a separate protocol with a 7-layered approach. Okay. Created a separate protocol with a 7-layered approach. It's not a protocol, it's set of protocols. Okay. It created a model with 7-layered approach, and it insisted that all vendors, all vendors, are you Cisco, if you're Juniper, or if you're Aruba, or if you're Fujitsu, whoever it is, you have to use this particular model and design your routers or switches or whatever it is. You have to design your devices which supports this 7-layered approach. Only then one vendor can communicate with another vendor. That was their basic idea. Okay. They wanted to implement intercommunication between different vendors, and that's the reason what they did. They actually brought up this 7-layered approach. And this 7-layered approach is now famous as OSI model. Okay. It's now known as OSI model. OSI model can be written as the first layer is application layer if you look at from the top. The second layer is presentation layer. Session layer. Transport layer. Network layer. Data link layer. Physical layer. These are the 7 layers that OSI or in ISO. ISO is nothing but International Organization for Standardization. They insisted that you have to use. And these 7 layers have different protocols. Okay. They have their own protocols. Let's actually deal with different layer. Now, what is a physical layer? Physical layer, in the sense, if you manufacture a laptop, say that you have manufactured a laptop or a router or a switch, something that you can touch is known as physical layer. The ports, the physical connectors, the voltage levels, physical data rates, these are the physical things that you see on the devices. That is known as physical layer. The cables, the Cat6 cable, Ethernet cable, fiber, these are the physical layers that you have for the devices or the routers or the switches. These are the, this comes under physical layer. Now, the next one is the data link layer. So we're actually going from the bottom because everything starts with the physical layer. Physical layer, why? Because only when you connect the cables, you have some connection between two devices. Okay. So from the physical layer, it gets started. What is a data link layer? Data link layer makes sure, so physical layer, let's assume that two devices are connected physically. All right. Two devices are connected through a cable physically. Now, what is a data link layer? Data link layer is something which actually makes sure that everything is formatted in a correct way. There is no error. It actually helps in error detection. Okay. And also, data link layer has something known as MAC address. It actually works with something known as MAC address. What is a MAC address? With the help of MAC address, you will be able to find the device where it is actually located. Okay. It uses something known as MAC address to identify every device. And also it makes sure there is no error. I mean, it detects the error, not completely eradicates it. It detects the error. Okay. So the data here let's talk about the data also. The data here in physical layer, when you connect the cable, I know you connect a power voltage, it is an AC. When it comes to a device, it is converted to a DC. So data is in the form of ones and zeros, right? Here, the data in the form of frames. The data is in the form of the same ones and zeros are in the form of frames. Okay. You have to remember that in the physical layer, the information is in the form of ones and zeros. When you go to data link layer, you call it as frames. Next, let's go to the next one. MAC address is something which is used in data link layer. We'll discuss about the MAC address soon. I'm just giving you a brief hint on that. Next is the network layer. Now, what is a network layer? Network layer is nothing but when you have connected the two devices. Let's say these are PCs. Okay, let me write it actually a bit. There are two PCs. Okay, two PCs connected. You know the MAC address of this one and MAC address of this one. They are able to communicate, and also they are connected to a router. So the router is also connected to another router which is connected to a PC. Okay, just imagining, just a hypothetical situation. So how do I make my data travel to another network? We'll talk about the network in some time. So what happens is every device has a IP address. You know that every device has a IP address. Two devices are set to be connected in one network only if they are not on the different router interface. If they are connected to a same router interface, say that this is a router and this is a switch. Okay, PCs are connected. PCs are connected. They are on the same router interface. So they are set to be connected in the same LAN with the same network. Okay. If they are connected to a switch, let's say PCs are all connected to a common switch, then they are set to be connected in the same LAN. So they are set to have the same network, same network. In the sense 192.168 1.0, 1.1, 1.2, 1.3, same network. Now, if you have to travel to another network, then you make use of something known as IP address, which comes in the network layer. This is just a brief overview. I'm also telling it again. So don't worry. We'll discuss what is an IP address, how does network react, what is a network, what is a you know different network, how do you identify a different network. We'll all talk about that. Don't worry about that. So for now, just remember network layer uses the protocol something known as IP. That is the protocol used in the network layer, IP. IP address is the address given to any of the network device, given to any network device which is a layer 3. On the layer 3 level, it is the address given to any network device. Okay. The main function of this layer is to find out on which network a particular device is. If you want to reach a particular destination, let's say you say that I want to reach 9.9.9.9. The main function of the network layer is to find where is this 9 dot network. Okay, where is this 9 dot network? That is the main function of the network layer. Let's go to the transport layer next. What is the transport layer? Transport layer actually takes care of the transport. Okay, how do you go to this 9 dot network? You found out where the 9 dot network is, but how do you go to that 9 dot network? That is taken care by the transport. Okay, transport layer. And the data here is known as datagrams, and the data here is known as segments. Okay. Transport layer in turn has two protocols. Okay. Transport layer in turn has two protocols. One is TCP, other one is UDP. Both help us in the same towards the same goal. Okay. Both work towards the same goal. What is the goal? To make sure how to reach that 9-dot network. Okay. What is the difference between TCP and UDP? For now, I'll tell you the basic difference. Okay, let's go deep as we are proceeding. This actually helps the data to be sent across in a reliable way. Reliable transfer. Okay. This is unreliable transfer. In the sense, for example, I am sending data from one device to another device. What does TCP do? Once it sends the data, it makes sure is the data being sent to this device or no. How will it make sure? Because it will wait for acknowledgement from this device. That is how it makes sure. But UDP, once it sends the data, it is done. It will not wait for any acknowledgement from this device. It will not expect also. Okay, that is how TCP makes sure that the data is sent reliably, and UDP does not care for reliable transfer. Okay, now what is a session layer? So after the transport you have a session layer. What is a session layer? Now say for example, from your device you are using multiple application. Like I'll tell you in layman terms, just understandable terms. You're using multiple applications. Let's say you have WhatsApp open, you have some web activities going on, you have Facebook open, Insta open. So how do you know that WhatsApp traffic is coming to WhatsApp only, web traffic is coming to web only, on the Internet Explorer only, and Facebook traffic? Once you send out the traffic on Facebook, how do you know it is coming back on Facebook itself? This is because of the session layer. What does session layer do? Keeps the sessions separate. Okay, it keeps the all the session separate. Okay, that is the it also maintains different session. It creates different sessions, it maintains different sessions, and keeps different information private. Okay, that is the main function of the session layer. Okay, next let's go to the presentation layer. Now what do you do with the presentation layer? Presentation layer. Now the data till now will be in the form of ones and zeros, right? Frames, data, datagrams, segments, everything will be in the form of ones and zeros because that is how the computers recognize the information, ones and zeros. But once it is coming to the screen, once it is coming to the screen of the computer, it is a human who is reading that particular information, right? So this presentation layer takes care that it is presented in a correct way. Okay, it is presented in a correct way on the screen in the human readable form. Okay, in the human readable form. That is the main function of the presentation layer. Now, finally, we have something known as application layer. Application layer is nothing but the applications that you use. What are the applications that you use? You might use Internet Explorer, where HTTP, it's your application. You might use FTP for file transfer. That is your one of the application. It is actually acting as a medium for humans and the computer. Okay, that is your application. Through this application, you are getting the work done. Okay, what other applications? WhatsApp, Facebook, Insta. These are other applications we have. Those are the application layer, which actually acts as a medium between the human and the devices. Okay. This is very important for the CCNA exam. For if anyone of you are writing it. So the 7 layers, let me actually put it again. Application layer. Let's go with the bottom. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Okay, these are the 7 layers used in OSI model. Why they are used in OSI model? Because OSI model is a 7 layered approach, so that all the vendors should be on the same page, should interact in the same way, so that they can communicate with each other. Okay, and this 7 layered approach, OSI model, was discovered by ISO, International Organization for Standardization. Okay, this is very important. You need to know that. Now, coming back to the OSI model, while working on one of the labs, I can show you that as well. I can show you how the each layered approach will be and how they are formed. You can, so I don't think so anybody would have seen any Wireshark capture. So I just have a, let me check actually if I have any. Let's go to this Cloud Shark. Let's see if you get things here, resources. And what is this tools? Cloud Shark. Okay, anyways, I'll just show it to you. I'll actually, while doing the lab, I can go to the Wireshark. I can use a Wireshark and show you the live example of that, of all the 7 layers that we have. That would not be an issue. All right, moving on. So when it comes to first CCNA, okay, when it comes to first CCNA or anything in networking, first of all, we always think, what are the devices that we use? So I know it's networking. Networking is a subject networking is some field. Now, if the networking is some field, what are the things that we use there? There might be many devices that we use there. If you can see my slide, I'll take it from layer wise. Okay. Hubs are layer 1 devices. Okay. There are some network equipments which are named as hubs. They named it as hubs. Okay. These hubs are layer 1 devices. And why were the hubs used? Why were the hubs even invented? Now, you have a PC, imagine. Okay. They first discovered a computer, PC1. They first discovered a computer. Then, having a computer only with you and you're not communicating anywhere outside the world, it is useless, right? Only you can see, no internet, nothing, because nothing is connected. Only you have the computer with you. Nothing. You just can play games on it. Even that would be difficult. Okay. Now, to connect to another PC, you used a cable. Okay. Okay. You use a cable to connect to another PC. Now, if you connect to another PC, you both can communicate between each other. Whatever files you have made record of something, you have made record of some sessions. You want to give it to somebody else. You both connected a cable between each other. You sent it. But what if there are 4 or 5 computers? It's not like you're using 4 or 5 cables. What if there are 25 computers? You can't use 25 cables. So they discovered something known as hubs. In hubs, what they did, they connected all the 25 computers to that hub. So basically, what a hub is a centralized point where all your PCs or computers can be connected. It is a centralized point, okay, through which all your devices can be connected internally. Okay, that is why hubs provide a centralized location to connect the computers or printers or other network devices. Got it? That is why hubs were discovered. Now, hubs were discovered, hubs were doing a good work, they were doing a good job, but the hubs, let me actually tell you how they behaved. When you have a hub, if one PC sends an information to the hub, it would go to all the PCs, all the computers. Okay. It was waste of time, waste of information moving through the hub, or waste of bandwidth. This person A, B, this person B does not need that traffic sent by E. B does not need it, but still he is fetched with that information. Even C does not need it. Still he is. Even D does not need it. E only wants to send it to A. But still no. Hub behaves like that. Any information coming from one port is sent out on all the ports except the port it came in. Okay? It is sent out on all the ports. So any computer connected to that port, it will be getting that information, hook or crook. Okay? That is how hubs were designed. Now, there came necessity where we have to invent another device. Why? Because hubs are actually flooding the information. There are more and more information on the network. Okay. If one sends, I'm sending it out on, all other ports. If say that there are, one second, guys, hang on. Okay. Sorry about that. I'm back. Okay. So there is much data on this circuit. If you can see, one computer sends an information, everyone are getting it. If you can see, if you only have little bandwidth assigned, okay, then all the bandwidth is eaten up here only because everyone are getting it, right? Even if he wants to get, even if he wants to communicate at the same time to a different computer also, he is getting that information also, he is able to send this information also. Like half of the bandwidth is being used there, right? So it is not a good idea. Everything is getting wasted. Lot of overhead on the network. So they invented something known as switches. Let's see what a switch does. Switches were invented later on. Switches were called as intelligent devices. Why? Because once you send the device, once you send the traffic from a device, and if you mark the destination device as B, this is A and this is B. Imagine this is B. Switches are very intelligent device that it will only send it to B. It will not send it to any other devices. How? And what is the mechanism that they use that they do not flood it? So switch uses something known as MAC addresses. Okay, MAC addresses. What happens? It stores a MAC table. You also have a MAC table in the switch. Whenever A is sending information and asking who is B, it will make a table, MAC table, and say that out of port 1, I have MAC address AB. From port 1, I have the information coming, and the MAC address I'm seeing is AB. And it is asking for B. It doesn't know where is B, or B MAC address is, let's say, CD. It is asking for CD. I don't see CD in my MAC table. What should I do? The switch will think over and it says, let me flood it. It will flood to all other ports. The one with CD MAC address will reply. So it will make sure, okay, on port number 2, I have CD. So the next time when A wants to send information to B, A wants to send information to B, on port 1, you have the information coming in, and it has already made sure that on port 1, I have AB, which is on the MAC table, and A is requesting the information to be sent to CD. CD I already have. I should send the traffic out on port 2. So this is how the intelligence is used by the switches. This is how they are called as intelligent, because they are able to see what is the MAC address coming in on a port and what MAC address is the destination MAC address, and do I have that destination MAC address in my table. If I don't have the table, if I don't have the destination MAC address in my table, then flood it on all the ports, asking who is that person. When a person replies back saying that I am so and so, make a note of his port and his MAC address. So MAC address, MAC table is filled dynamically. So if somebody asks you how the MAC table is filled, it is filled dynamically by sending information. Once the information starts, only then the MAC table also starts filling up dynamically. No administrator before writes anything in your MAC table. It is all learnt by the switch. Switch actually learns what MAC address is connected to its ports and it updates its own tables. Okay. That is why switch is an intelligent device. Okay, that is about the switches that you have. Next, network device that you use in networking after hubs and switch, you have access points. Access points nowadays, I think everybody are using Wi-Fi, so you should know what is an access point. Access point is nothing but your Wi-Fi router. Okay, it's an access point. It actually provides us a wireless connection. Okay, so whenever you have a wireless client like your laptop or maybe your phone, you send an association request to that access point. May I join? And the access point replies back saying that yes, you can join. Please enter these credentials. Authentication is successful, then you are a wireless station. You're called as a wireless station because you're also one of the wireless clients. Okay, you're a wireless station. Access points is one of the devices that you use in your network. They are similar to switches. They do the job of switching itself. But only thing is, as we discussed earlier, layer 1 devices, hubs, these are centralized locations. Okay, these are centralized location to connect your computer. Similarly, even switch is a centralized location where you connect many computers. But only difference is switch is connecting many computers with a wire. But access points connect to many computers without a wire. It uses a antenna where it radiates signal. Okay, where it radiates the signal, and through that wireless signal, you have many computers connected. This LAN is known as, or this local area network is known as wireless LAN. Okay, what about this LAN? This is a wired LAN because it is connected through wires. Access point is connecting same computers without wire. It is known as wireless LAN. Okay. Next thing is a router. A router is always a layer 3 device. Why it is known as layer 3 device? Because switches run on MAC address is the address burnt on your NIC, network interface card. Okay, it is a 8-byte address burnt. They will actually burn that address on the network interface card. Okay, but layer 3 address or the router's address, it's a logical address. It's an IP address, logical address given to a device to identify the device. Okay, usually routers are used to provide the WAN connections. So if you want to connect computers in the same house, same network, then you use switches, hubs, then it becomes a LAN, same LAN. But if you want to send the same information to another network, then you use routers. Router is a person or router is a device which connects two different LANs. Okay, two different LANs. Somebody is okay. Two different LANs. Branch office, like let's say your head office and two branch office, they are connected via routers. For connecting to internet, we need routers. Okay, because router is a device which connects two different LANs. After that, we have another device which we use in our networking. That device is known as firewalls. So what does firewalls basically do? You would have actually learned in your corporate network also. Firewalls is actually used to restrict the data coming in from the internet. Okay, you have all the setup done on your end. You have an office network, you have a lot of computers, Okay. These computers are connected to switches. Okay. Switch is connected to a router. Router is connected to a firewall. Now, why it is connected to firewall? Because I don't want anybody sitting outside on the internet to access my router. I don't want anybody to access my router or anybody to access my internal LAN where I have the private information. So I keep a firewall here. Any address which I don't know, don't allow him inside. Don't allow him inside. But from internal traffic going outside, yes, allow him. Okay. For this purpose, I use firewall. To filter unauthorized packets. It allows the packets going out, but coming in will be rejected. The response packet coming from outside is also allowed. So basically, it is used to give security to our LAN. Okay, that is the basic idea of our firewall. Now, next we have is IP phones. When you say IP phones, these devices were working as voice over IP. Voice over IP. Okay. So before you were actually using the telephone lines. Okay. If you had to make a trunk call, you were using the telephone lines. Now it's not like that. You can use the internet to make calls from one country to another. Okay. That is the major difference that we saw in the telephone industry recently. For those purposes, we use IP phones. They can be connected in the LAN. We can allow the voice traffic going over the existing network. Okay. And also we can receive the data, send the data. Okay. As you can see, before the networks were only meant for sending and receiving the data and sharing the resources. But today's network, we can use voice and videos as well. Also, video conferencing is possible due to these IP phones, which use both voice and data. Okay, that is the actual advantage of using IP phones. Wireless router, as I told you, Wi-Fi router, which is nothing but similar like access points, which are used in our houses. They actually provide you some signals, radio frequency signals, for which you can connect and also start using the internet, that too without a wired connections. Okay, that is the use of this wireless router or DSL router, home router. Now we know the certification track of Cisco. I don't think so you need to go through this again, because you know that Cisco provides, you know different fields, the education in different fields like routing and switching, security, service provider operations, voice, wireless, design, data center, collaboration, video. So on multiply on these you have associate level, expertise level, and then uh, what do you call, what is the next one, professional level, sorry. Okay. CCNA, CCNP, CCI, this was actually before, now it has changed. This was before, it was like this, it was CCNA, CCNP, CCI. Now also it is, but the tracks have been changed with the codes. Moving on, we can move on to the TCP IP addressing, but if you have any questions, just making sure if you guys are okay, if I can move on, you have no questions. Okay, I'll take that as none. TCP/IP addressing. IP addressing, TCP/IP addressing.
Excuse
What
me, sir.
is? Yeah, sure. Go ahead.
Sorry to interrupt.
No
Yeah, I
worries.
just wanted to confirm what is difference between access point and routers. Is there any difference?
That's right. Access point is nothing but your layer 2 device. Okay. It actually provides connection in the LAN.
Mhm.
But router is a layer 3 device which actually provides a WAN connection. Okay. Access point is nothing but a switch. So you have a switch connecting multiple computers together, right? You connect multiple computers together to a switch. Similarly, access point also does the same job, connecting multiple computers together but without a wire. Okay.
Okay,
Same way. But router is something which actually sends that same information to a different network
different
using,
network. Yeah.
yeah,
So difference between access point and switch is only that connectivity, wired and
wired and
over and over.
wireless. That's right. Exactly.
Thank you.
No worries. Thanks for the question. Okay. Moving on. We have a protocol. What is a protocol? Protocol is a set of rules or procedures that must be carried out for better or proper communication. Now, when I said TCP/IP is a protocol, TCP is a protocol, UDP is a protocol. Now, what does a protocol mean? Protocol means it's a set of rules or procedures that must be carried out, something like checklist. Okay. It has to be carried out in order to ensure proper communication, better communication. If you need two network devices to talk with each other, you need to follow set of rules, a protocol. Okay. If you need two network devices to talk to each other. Now, we actually, OSI model was not the first model which was proposed. Before that, they 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 had proposed many different models, which is nothing but TCP/IP, IPX, SPX, Apple Talk by Apple, NetBIOS by Microsoft, and then the last one was OSI by International Standardization Organization. These were the proposed ones, out of which OSI standardized the OSI model. Okay. I mean, ISO standardized the OSI model. Let's talk about the TCP/IP addressing. Now, what is TCP/IP addressing? Initially, as I told you, everyone had their own protocols to communicate. Then, OSI model came into effect, and everybody had to communicate using the same protocol, same model. If two devices had to communicate, they had to support all the TCP/IP protocols, right? Then they discovered something known as OSI model. Okay, this is the same slide. It's a standard protocol. Okay, that's okay. Now, IP addressing, TCP/IP addressing. So, any device on the internet, how do you identify it? Just like humans. Okay, we need something to identify every individual. In the same way, in the network, you need to identify the devices. How do you identify the devices? One, at the layer 2 level is by the MAC address, at the layer 3 level by IP address. Okay. Devices recognize each other with IP address and communicate. Now, what is an IP address? IP address is not a physical address like your MAC address. MAC address is a physical address. It is burnt in the sense it is, what do you say? It is induced in your network interface card. Okay. But IP address is a logical address that we assign to the devices. Now, there are two versions of IP address. Internet Protocol addresses, which are IPv4 and IPv6. This IP protocol version 4 was discovered in the 1980s. It is a 32-bit address. Now, by the way, if 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 someone is not aware, excuse me, guys. Now let's say this is 10.10.10.1. This is an IP address assigned to a computer. Let's say this is a 32-bit address. For our convenience, we write it in this way. Okay, but actually the computer sees this address as it's a 10 dot address. Okay. Yeah, that's right. Sorry. This is how the computer sees it. Okay. This is the address in binary. You know that the computer actually reads everything in a binary form in zeros and ones. Even the address is actually read in binary form, that is ones and zeros, for our convenience, so that human readable is good. For human readable form, we use 10.10.10.1, that is a decimal form. This is a decimal form, this is a binary form. Okay. Now, coming back, this was discovered in binary. You have 8 bits. 8 bits make 1 byte. Okay. 8 bits, like that, you use 4 separate 8 bit. 8 bits is called as a bits. A group of 8 bits is called as a byte, or also called as a octet. Okay. 8 bits together, it's called as a octet. So 4 octets for an IP address, or 4 bytes. Okay. So 4 bits, 4 bytes of IP address, in the sense 4 8s are 32-bit IP address supported. Okay. Then before, you knew that only, in 91 or 90, one or two houses had a computer. That's it. We did not see a computer at all in many places. We just had one or two for an area. So they didn't expect the growth of the internet. So since it started growing rapidly, the IP address became, you know, diminishing. Like, you had IP addresses which started being assigned to every other computer. Now we are out of IP address already. We are getting, I mean, we are almost done with the IPv4. So what they did, they started inventing another version of IP address, which is IPv6, which was discovered in 1999. Okay. And also, along with that, they came up with another solution known as NAT, which we will discuss further in our lessons. Okay, when we come to that NAT topic. So using NAT also, it is one of the way to actually, one of the solution to save the IP addresses, to save the IP addresses. We are actually surviving. We are surviving with the IPv4 addresses because of the solution known as NAT. Okay. Now, what's IPv6 address? IPv6 address, similar to what we discussed. We just discussed a 32-bit IP address, right? 32-bit IP address for IPv4. Imagine a IPv6 with 128-bit addresses. 128 in the sense each 32, 32, 32, 32. 32 here, 32 here, 32 here, 32 here. Okay, that makes 128. So IPv6 address is 128 addresses. Give me a minute, guys. I'll just have some water. Okay, I'm back. So yeah, moving on. IPv4 addresses is understood by the network devices in a binary form. But as I told you, but for human convenience, we actually put that in a decimal form. Okay. I showed you an example of so as 10.10.10.1. Similarly, this is one of the examples. 85.01.01.01.01. Okay. Similarly, this is how the conversion is. So if you want me to go ahead and show you the conversion, I can show you that conversion as well. But we have that, yeah, in the next slide, we have that conversion table. So I think we can do that. Okay, let's actually do this conversion. Let me actually tell you how it is converted. Few people actually have joined here for CCNA. So I think, I mean, for the people who have joined for CCNP, they already would have known the conversion. But few people who are here for CCNA, I think they would need the conversion. So let's actually go ahead and do it. So every byte, so every bit, we always start from the right side. The right side starts with 2 power 0, 2 power 1. So binary is nothing but you have 2 power. Binary is nothing but the power of 2. 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8. Okay. 8 bits in an IP address, right? That is why 2 power 8. These 8 bits form 1 octet. 1 octet or 1 byte. 4 bytes like this make an IP address. Okay. Now, let's take an example. Now, 2 power 0 is what? 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. 2 power 8 is 256. Now you should already know no IP address will start with 257.4.6.1 because 256 is the last one. Okay, that too we don't use 256. 255 is the last one. 255.255.255 is the last one. Okay, we never use 256 also. So any IP address after 255 is termed as invalid. Okay. Now, let's say I have to 85. I have to convert into binary. Now, 85 into binary is adding what all you get 85. 120. Can I take 256? No. Can I take 128? No, because it is more than 85. Can I take 64? Yes, I can take 64. If I take 64, what else I can add to? If I add 32 to 64, if I put this as 1, 0, 0, 1, if I take 64, if I add 32, it will be 196, right? It will not become 85. It will become 96. So I'll not take 32. So I'll put 0 in this place. Can I take 16? Yes, 64 plus 16. How much it'll be? It'll be 80. So I can take that. Yes. So I'll put 1 here. Can I take 8? So 64 plus 16 is 80 already. If I take 8, it'll become 88. So I won't take this. Can I take 4? Yes. It'll become 84. Can I take 2? No, it'll become 86. So I'll not take this. I'll take this. So the binary address is 001 0101 01. Okay. Same thing, which is converted here. 01010101. I think this is wrong. This is written wrong. I have to convert it. 001 010101. Yeah, looks good. Let me check. 001 01010. Oh, I'm sorry. 256 is not. I'm so sorry. 2 power 7 is the last one. I cannot use 2 power 8 because I'm using 0 here and it's 0 to not 8, it is 0 to 7 because it is 0, 1, 2, 3, 4, 5, 6, 7. So it will be 8 digits already. So it is not 2 power 8, it is 2 power 7. So adding all this, you will get 255. 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240. 248, 252, 254, 255. So adding all this, you will get 255. So 255 is the last IP address that you can use. And coming back to our, this one 85 is written as 01010101. That's right, because 2 power 8 is not counted. Okay, so sorry about the confusion. Just for the confusion, let's do it. Let's do one more. Okay, and the other IP that I have is 192.168.10.1. Okay, so if it is 192.168.10.1. Okay, now let's go about converting this. 192 is written as, let me write the twos table, but I can actually write it as 128 plus 64 is 192. I know that, but if you want me to show that in twos table, I have to take this 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, 2 power 0. Okay, which is nothing but 128, 64, 32, 16, 8, 4, 2, 1. So how do you get 192? If you add the first two bits, it is 192. So 11000000. How do you add 168? 128 plus 64 is how much? 192. So you will not get 168. 128 plus 32, it is 160. So I can take 101. Adding these two, I'll get 160. Then 2. Okay, 00010. Okay. Then 10. How do you get 10? 10, we can do it as 8 plus 2. Okay. So it is 0, 0, 0, 0. 8 is 1. 4 is 0. 2 is 1. 0. How do you get 1? Last digit is 1. So I'll just write 0, 0, 0, 0, 0, 0, 1. Okay. Sorry. 0, 0, and 1. So it is nothing but 192.168.10.1. So this is how you actually convert, or you actually convert from binary to, from decimal to binary. Okay. Moving on. So you can do that vice versa as well. You know that this is 2 power 7, the last one is 2 power 7, and this is 2 power 6. So 128 plus 64, 192. You got it. Then this one, you can convert the in the same way. Okay. That is how you actually convert it. So doing this is already in the binary. You have to convert it to decimal. Okay. Let's go to the next one. Next one is assignment of IP addresses. Now, on your computer, if you go to network places, control panel, change adapter setting, then you can assign the IP addresses. Okay, let me show you that. So go here, say control panel. Okay, when you go to the control panel, go to network and internet. When you go to network and internet, go to network sharing center. On the left hand side, you have change adapter settings. Click on change adapter settings, Ethernet to properties. You have something known as Internet Protocol version 4. Right click on it. You will see two options. One is obtain an IP address automatically or use the following IP address. Okay. When you click on obtain an automatic IP address or an IP address automatically, then what you have to do is you can give a DHCP server. Okay, you will assign a DHCP server, which we'll discuss later on the same. Anyways, we have a topic of DHCP as well in our this one. So this you will select only when there is a DHCP server which is actually assigning IP addresses to your computer. But if you do not have a DHCP server, you say use the following IP address, then mention the IP 10.10.10.1, something like this. Okay. Say anything, but I'll not assign it to this computer. Then say subnet mask 255. Yeah. By default, it will take class A subnet mask. We'll discuss about the classes in the future. And the default gateway, which is the next hop router that you need. Okay. And then say okay. I'm not going to say okay, but this is how you assign the IP address. Let me show you again. So just go to your control panel. Control panel. Network and internet. Network sharing center. Change adapter setting. Any Ethernet. Go to properties. Internet Protocol version 4. Use the following IP address and mention your IP address, mention your subnet mask, mention your gateway. And let's see if I try to assign the IP address with 256, what happens? Do you see the error message here? 256 is not a valid entry. Specify a value between 1 and 223. Why 223? Because 224 is also not possible to assign to any of the devices, because 224 onwards, the IP addresses are kept for multicast address. It is only used for multicast purpose. So You can only use from 1 to 223. Okay. Let's see 1.1.1. And then what if I give 0? Let me actually get back to that. Okay. As I said, dynamically obtain the IP address, manually enter the IP address. You have two options. I told you that dynamically assigning IP address and uh, manually assigning. Now, why do you use dynamic and why do you use manual? That is the thing that we're looking at. So, manual in the sense, at your home, you just have one computer or two computers. You can directly go assign it. Okay, one is 192.168 1.1. The other one is 1.2. You can assign it. Okay. You will not find it very hard. But what about in an office environment? You have hundreds of computers. Assigning each one of them, going to each one of them, assigning IP address to each one of them will be a very time consuming task, right? That is the reason we use DHCP server. Why DHCP server? To assign the IP address manually, dynamically, automatically to a computers, to all the computers, we use a DHCP server. How DHCP server is programmed? Simple. We mention a range of IP address on the DHCP server. This is the range you have to use. Okay. We mention that range on the DHCP server, and once the DHCP server and the computers are started and we mention the DHCP server on the computer, then from the given pool of IP address, from the mentioned pool of IP address, DHCP server assigns the IP address to all the computers. That is very simple. Okay. Now, to verify the IP address on a computer, now if you want me to show what my IP address is, I'll just go to command prompt CMD. Okay. Just say ipconfig. This is my IP address. Okay. Now I'm not using Ethernet. I'm using DHCP. So that's the reason you're not able to see it. Auto configuration addresses. This one, this is APIPA IP address. This is the IP address for Ethernet 2. As you can see, 172.16.24.27. This is a private IP address that I'm using. Okay. This is also a private IP address, VMnet. This is also a private IP address. So if you want to look at your computer's IP address, just go to your computer, say ipconfig, type in the command ipconfig, and you will be able to see the IP address assigned. Okay. And also not only IP address, that also gives you the subnet mask gateway DNS primary. I didn't show you that. I'm so sorry. Let's go to ipconfig. As you can see, not only the IP address, you have subnet mask, you have default gateway, and apart from that, you have DNS server address as well. What is the DNS server? Okay. I do not have any DNS assigned. It is not connected to the network. Okay, while doing the lab, I'll show you the DNS servers assigned as well. So you'll have two DNS servers. One is the primary one is the alternate one. You will have two DNS servers assigned. Next, now we are talking about something known as classes. So in IP address, we have something known as classes. Class is something that you need to know. It's very important. Now, our IP addresses. So I told you that our IP addresses are actually, designed from 1 to 255, right? You just saw me that I was able to give an IP address from 1 to 255 only. So from 1 to 255, we have divided the IP addresses into 5 classes. What are those classes? As you can see on the screen, 5 classes. The classes are class A, class B, class C, class D, and class E. Okay. Class A is ranging from 0 to 127. Okay. From the IP address starting from 0 to 127. In the sense, on the first octet, I'm talking about. I'm not talking about the other octets. The first octet I'm talking about, this one. This one, this first octet ranging from, okay, 192. Here it is 192, but the first octet from 0 to 127, that belongs to class A. Okay. The first octet, if it is in the range of 128 to 191, then we say that the IP address belongs to class B. If the first octet is in the range of 192 to 223, then we say that the IP address belongs to class C. If it is between 224 to 239, we say class D. If it is 240 to 255, it is class E. Okay. Class A, B, and C are the main IP addresses which are used in LAN and WAN networks. Why A, B, and C? You also saw me giving the IP address as 244 or 254, and it did not take it because A, B, C are the main classes. Up to 223 is the IP address that any device will accept. After that, it is used for experimental purpose and also for multicast. Okay. Class D is for used for multicasting. Class E is for used for research and development purpose. The first and the last IP addresses can be 000, all zeros and all 255s. Okay. As all the bits can either be 0 or 1. If they are all 0, then we have the first IP. If we have all ones, then we have the second IP. Now, we discussed about the IP addresses. Now, without communication, discussing about the IP address is not good. So, first of all, what kind of communication we have? First of all, we have unicast communication, that a person talking to another person is known as unicast communication. Multicast communication. What is a multicast communication? A person talking to a group of people is known as a multicast communication. Broadcast. Person talking to every one of them is known as a broadcast communication. Similarly, in network topology, a device talking to another device is known as unicast. A device talking to a group of devices is known as multicast. A device talking to everyone, all the devices is known as broadcast. Okay. For multicast, we use a separate class of IP addresses, that is 224.0.0.0 up to 239.255.255.255. This is the class of IP address that we use for multicast, as I told you earlier. Okay. What is a broadcast? Where do you use? So while discussing about the switch, if you remember, I told you that if the switch does not have any entry in its MAC table, okay, any entry in its MAC table, then it floods to all the ports. That is known as broadcast. When it doesn't know, when it does not have any entry in its MAC table, it floods through all the ports except the port it received the information on. Okay, it floods through all the ports. That is known as broadcast. Those are the three types of communication we have. Now for a multicast, as like, let's say you want to have some Netflix or something, Netflix group you want to join. So first you have to register for that particular group for a multicast communication. After which you keep getting that alerts, or even your device will be considered as one of the device in that multicast address. This I showed you on a system. When we try to, you know, put an IP address more than 223, it will not take it. Okay. And in the LAN, whatever devices it is, it will take only from 1 to 223. Skype uses multicast traffic. Okay. Skype, as you know, Skype, when you're making a meeting or something, or a Skype call, you always tend to use a multicast address. Now, when we discuss about the IP address, so what just to, you know, make that fix in your mind, I'll just repeat it again. First, we spoke about the IP addresses, right? I told you what an IP address is. IP address is how many portions are there in the IP address. And I also told you that there are 4 bytes, that is 32 bits of IP address. And depending upon the first octet, 4 classes are defined. Okay, 4 classes are defined. And also IP address is used for communication. What all types of communication we have? Unicast, multicast, broadcast. Okay. Now, in the classes, I'll show you in an IP address what is a network portion and a host portion. Now, let's imagine class A, for example. Class A. Okay. Class A. Class A is from 0 to 127, right? 126. 126. Why 126? Because 127 is used for loopback addresses. Okay. 0 to 126 is our class A. Now, in class A, it is always written as, let's say, for example, the default subnet mask for class A is /8, that is 255.0.0.0. Now, when you saw my computer, okay, when I go to control panel and network and internet, network sharing center, and change adapter setting Ethernet 2, and then when I try to give a 10 dot address, observe the subnet mask it takes. What did it take? A default subnet mask, which is 255.0.0.0. Because for all the class A's, the first portion is considered as a network portion. All the other 3 is considered as a host portion. If you understood. or no? Let me. So there is a group of networks. There is a group of networks. This is a PC. These are the PCs connected to a switch. It is connected to another network. Another switch. PC, PC, PC. Okay. Now, when I say 10 dot network, it is used to identify a particular network. For 10 dot network, go on this interface. So this is a 10 dot network. What is a network? First of all, a network is nothing but a group of devices. Group of devices. What is a host? A host is nothing but a particular device. Particular device. So here, this group is known as a network. Okay. And this particular host is known as a host. This particular device is known as a host. So if I say 10.0.0.0/8, that identifies this network. If I say 10.0.0.3, then it identifies this particular computer. Okay. If I say .3, it will identify that particular host. That is the difference between a particular host and a network. Okay. You might be asked what is a host and what is a network. So class A, in class A, what they do, they have divided one portion as a network portion and all others as host portion. Now, with this, if you can observe, one portion is a network portion, others are all host portion. So 2 power 8 2 power 8 is network. Why 2 power 8? Because every decimal value here is nothing but 8 bits. 8 fours are 32, right? So it has 8 bits over here, 8 bits over here, 8 bits over here, 8 bits over here. 2 power 8. So possible networks is nothing but 256 networks are possible. How many hosts are possible? 2 power 8, 2 power 8, 2 power 8. It is nothing but 2 power 24. So it is almost 16 million hosts which are possible. 16 million networks or hosts possible in class A network. 16 million, more than 16 million. Not 16 million, I think it's more than that. I've just written here. Okay, 2 power 24, which is equal to, yeah, 16 million IP address. That's right. In class A, we have one network portion, 3 host portion. Okay. In class B is written in this way: 2 network portions, 2 host portions, that is 172.16.0.1/16. The default subnet mask 255.255.0.0. Okay. This is the default subnet mask of class B. Now, what about class C? It keeps reducing. Network, 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 host. That is 192.16.1.0/24. Okay. Here it was 8. Here it was 16. Here it is 24. Okay. So for class A, one network portion, 3 host portions. For class B, 2 network portion, 2 host portion. For class C, 3 network portion, 1 host portion. So here 2 power 16, 16 billion networks possible, 2 power 16, 16 billion hosts possible. Here 2 power 24. How many networks possible? So many, 16 million networks possible, 2 power 8. Only 256 hosts possible per network. Okay. Default subnet mask is 255, 255, 255, 0. Okay. That is the way how these network and class portions, network and host portions are bifurcated on the classes. So always remember you have 5 classes A, B, C, D, E. A, B, C are the genuine classes in the sense, real classes in the sense you can assign it to a computer. D and E you cannot apply it to a computer because D is nothing but the multicast used for multicast. E is used for research and development. And further in the classes, they have divided these classes into network and host portions. Class A has 1 network portion, 3 host portions. Class B has Class B has 2 network portions, 2 host portions. Class C, 3 network portions, 1 host portions. Okay. So network and class portions are not the same in all classes. We saw that it was changing. If you need a network, so let's actually take a practical example. Now let's say you have your own organization and you need around 250 computers. Which class would you go for? Obviously C class, right? Why? Because C class has how many hosts? 2 power 8, which is 56. Because you need 256 computers, 250 computers, okay? 250 hosts you need. So you'll go with the C class, right? If you suppose, let's take it, if we need around, can you guys tell me if we need more than 250 computers, 250 hosts, can you guys tell me which class would you opt? Which class would you go for? Anybody aware of it? Or anybody know the answer? Okay. So if you need more than 256 hosts, you need to go to class B. Okay. We need to select the class B because class B supports the number of hosts which is more than 256. If we need more than 64,000 or 65,000 or 66,000, let's say, then we need to shift to class A because more than 66,000 hosts are only provided in the class A networks. Guys, do you have any doubts? Guys, are you following it? Everyone are sleepy? All right. I think most of the guys are sleepy. Anyways, we have come to the end of the session. We can continue with the session, the second session tomorrow. So tomorrow, actually, I'll be sharing with you on the network ID, broadcast ID. We'll be talking about the subnet mask. We'll be talking about the private and public IP address, as you see on the screen, and also we'll see what is subnetting, what does subnetting mean, what are subnetting concepts, and we'll also take some subnetting examples tomorrow. Okay. So these are the topics that we have for tomorrow. Uh, I know most of them are sleeping tomorrow. So tomorrow a class will be quite interactive. So you will learn about subnetting. You'll know how to, create different networks depending upon the requirement of your company or depending upon the size of your company. Okay. So thanks a lot for joining in, everyone, for today's class. Have a good one. Thank you, guys.